Kia ora. We're having a look at page 21 of the WalkerMaths calculus book for level 2. The example I've picked is find the gradient when y equals 3 for y equals x bracket x minus 2. Now this is a similar question to all of these. So on all of these questions they give you a function and they want to know what the gradient is when y is at some value. The reason this page is difficult for a lot of people is because normally when you're finding a gradient you're using an x value. So what we need to do is we need to find the x value before we even begin. Right? So what we're going to do is straight away before we differentiate we need to know what the x value is when y equals 3. So we're trying to work out first x equals what. But the other thing is sometimes there's not going to be just one x output, there's going to be two x outputs. Let's have a look at the graph to see why. So our graph, let's expand this first. So for y equals x times x is x squared, x times negative 2 is minus 2x. We can see what shape is this. This is going to be a parabola. So, and it's a positive parabola. So actually when y equals 3, there's going to be two values for x. There's going to be this value and this value. Let's have a look at them. So on here I'm just going to type that in. X bracket x minus 2. You can use this if you want, by the way, at home. And we're trying to find out when y equals 3. So let's have a look at this. So it's a parabola, and we can see there's actually two places where y equals 3. So those are going to be our two x values. And let's find out how to find those x values first. So in order to find them, all we need to do is substitute this 3 into the original function. So it's going to be 3 equals x squared minus 2x. We're going to need to solve this, and in order to solve it, it needs to be in quadratic form because it's got this power of 2 for x. So I'm going to minus 3 off both sides. 0 equals x squared minus 2x minus 3. Now we could use our graphics calculator to solve this, and I will show you how. So we'll just go into equation, polynomial, degree 2. The value of a is 1, b is negative 2, and c is negative 3. And that would solve and find us the two x values, one being 3, the other being negative 1. But let's just factorize it because we can. We're going to have x and x. We need to multiply to get negative 3 and add to get negative 2. Well, to do that, we're going to have to minus 3 and plus 1. Because negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. Boom. Okay, so that means it's solved. These values happen at x equals 3 and x equals negative 1. Normally I would prefer to put them in order, but it doesn't really matter for this question today. So there's actually going to be two places where we need to find the gradient. Not just one place. We want to know what the gradient is when x equals 3, and we want to know what the gradient is when x equals negative 1. So maybe I should just note that down in a way. We want to know m equals what when x equals negative 1, and there's going to be another gradient, m2 equals what when x equals 3. So now we've got two things that we need to input into our derivative so that we can find our gradients at those points. Okay, so let's have a look. So let's find the derivative. We're starting with y. I might just put a box around that and show you that I'm finding the derivative for that down here. So we can go with either y dash, or we can go dy by dx when we're dealing with y, just for notation. I like dy by dx because it's change in y over the change in x, and that's a nice way of defining a gradient. Gradient's all about change. So dy by dx, ooh, we can't actually differentiate that with our current knowledge, so let's expand that. So it's actually y equals, wait, we expanded it before, it's just here, my bad. Let's use that one. So the derivative of x squared is 2x. We just multiply by the power and then reduce the power by 1. And then this one here is going to be minus 2. We just multiply by 1 and reduce that to x 0. So this is the derivative. So then let's start with x equals negative 1. So I'm even just going to write this. I do this usually. I write at x equals negative 1, the gradient is, and then we'll use this, 2 times negative 1 minus 2 equals negative 2 minus 2, negative 4. So the gradient is negative 4 when x equals negative 1. Now let's find the other one. At x equals 3, m equals 2 times 3 minus 2 equals 6 minus 2, which is 4. So it's found two gradients. So when it says find the gradient, I probably should have made that find the gradients when y equals 3. Let's have a look at the picture. So I'm going to expand this a little bit. Oh, and I can't. I've cut it off using this program. Oh well. Let's just have a look at it in here. So pretty much we've got our function. Let's turn on the derivative. So we found our two x values here and here. Now the derivative looks like this. And when we substitute into the derivative, I'll turn this on real quick. When we substitute this value in, so that was when x equaled negative 1, we can see here, come on, we can see that the gradient is negative 4. So at that point where x equaled negative 1 for that first y value, the gradient there is negative 4. See that triangle's angle? It's going down 4 and across 1. Then we'll drag this over to our other x value we were finding a gradient for. Oopsies, I'll make this a bit bigger. We want it to be at 3. So when we drag it across to here, you can see that the gradient is positive 4. So the gradient's just being outputted for you there. So the triangle here is going across 1 and up 4. So pretty much that's a visual reason why. So we're looking for when y equals 3, we find those two x values for that point. Sometimes it's 2, sometimes it's 1. It could be more, but I doubt they would ever hit you with that. So the two values we found were 3 and negative 1. Then what we did was we substituted those values into the derivative, and then that was used so that we could find our gradients at both of those points. Now, there's a few more tips that I want to give you because there's some little confusing bits on these. This question here overall is really confusing. It's meant to teach you the concept that this is, yeah, I don't want to give too much away. This is the function, these are the y values you're substituting in. They didn't make that super clear. Here, that's straightforward enough. That's just the same as being y equals 0. This one's a little bit tricky where the curve crosses the x-axis. So let's have a look over here. Where does the curve cross the x-axis? It's when y is equal to 0, right? Because the whole point in the x-axis is always at when y is equal to 0. Another few here to think about. Some of us may not know where an origin is. Oh, there wasn't actually a question about the origin. The origin in maths is 0, 0. So over here is the origin. Otherwise, they might be a little bit more straightforward other than that.